Mr. Daniel Egger from Axiros to you, because I think he's already known since many years, if not decades, to more or less everyone here. He's subject matter expert, formerly on TRO 69, since the time it has been invented, around 2004, I guess. And now he's also acting as stream lead at the Broadband Forum. Stream lead is correct, Daniel?
Yeah, for data modeling, exactly.
Yep. For the USP topic, he's the one who brings back, let's say, the requirements from our customers into the standard. He tries to optimize the standard with a team there at the Broadband Forum. And I guess he's the one who knows everything about USP. Daniel, your stage.
Would hope so. Okay. Welcome, everybody. It's a great pleasure to be here and have the second to last talk, I guess. Yeah, so I've been given a very much not trivial task to introduce you and tell you everything about USP in 40 minutes. So yeah, it's quite a challenge, and I think I try something different today in order to make it possible in that short amount of time. So what are we doing today? Basically, I'm trying to give you an introduction into what makes USP. So what are the use cases? Where does it come from? How does it fit into the general scheme of management protocols that we have nowadays? And yeah, I wanted to have an introduction basically starting from the ground up, going into some more elaborate topics, also mentioning how those could be used, and basically make you the next USP hero and give you a sense of what you might want to try yeah, when you're back at home and if you want to look into the sphere. So basically, this is going to be you after the next couple of slides, I would hope. So let's start easy. So let's start easy. Basically, we start with an introduction, right? So the guy is already on the first step, since most of you already have some knowledge of Tier 69. So at least you have some idea what device management protocols are, what you can do with it, what some of the use cases are. So you're not starting from zero, you're already on the first step. So let's see. First step, of course, is what is USP? It's also known as Tier 369. You've heard a lot about that during the last couple of days. It's basically a device management protocol standard. It was introduced by the Broadband Forum, or specified by the Broadband Forum. It follows a few basic principles. So basically, you have two entities in your system. One is the controller, which is also what we call the server, or in Tier 69 terminology, it would be the ACS. And of course, we have the devices that we actually want to manage in the field. And those are called agents in that terminology. And in Tier 69, you might also refer to them as CPEs, so customer premise equipment. But as it actually turned out, you know, Tier 69 was designed a long time ago. And as it turned out, you can manage more devices than those that are located in the customer premise. So they basically decided to get rid of CPE and just call it an agent. It's specified by the Broadband Forum, so it's a regular standard that you can also download directly from the Broadband Forum, look into it. You can also become a member of the Broadband Forum and basically help shape the standards and help it evolve. If you're willing, there are actually lots of member companies in the room. So if you're already a member company, then you can basically just go to the meetings and join the discussion and help shape it. And actually, it's supposed to eventually replace Tier 69, because over the years, people have figured out that Tier 69 has a couple of drawbacks or some use cases that cannot be easily implemented with it. And of course, you don't want to have multiple protocols around that do the same thing. So the idea is eventually to get rid of Tier 69 and just replace it by USP. So congratulations, that was already the first step. So I hope that was an easy one and I didn't lose anyone along the way. So let's talk about connectivity. So how does it work on the low-level front? USP has one big difference to Tier 69 in that it is supposed to talk to multiple servers. So there is no single ACS anymore, but you actually have those controllers, and those controllers can exist multiple times, also to facilitate different jobs. So one thing that was needed in order to make that possible is you need to have some form of addressing. So it's not just enough to say, you know, this is my ACS. I can reach it using this URL, but you actually have to address those endpoints somehow. And on the device side, you already had that using the typical, you know, OUI, product class and serial number scheme. But nowadays we need it also for the controllers because, yeah, there can be multiple and you want to identify them. So now we are calling those controllers and agents endpoints. And endpoints, in order to address them, they need to have an identifier. Identifiers can be chosen from different kinds of classes. So you still have your typical OUI and serial number scheme, for instance. So this is an AVM device, I think. So you have your OUI dash serial number, and that's basically your endpoint ID. So it's very similar to what you would use in Tier 69. But there are also other possibilities. So you could have an EMI for a mobile device. You can have various other ways of addressing devices. And for servers, typically you want still to use something like a fully qualified domain name. So we introduced the FQDN identifier. So that's called a protocol scheme or an endpoint scheme, and you can still use FQDN and then say, you know, this is, for instance, USP@axiros.com, or this is, you know, controller.vodafone.de or whatever. Those endpoints, they have very strict requirements, so they need to communicate, of course, between one another. And in order to do that is you have what is called an MTP. So there are multiple MTPs to choose from. We have already heard, you know, some people prefer WebSockets for very good reasons. Others use MQTT. There are also other defined ones like Stomp, but actually the only company I know that uses Stomp is Ventiva. So not sure where that is going, but it is available. And there was another one called CoAP, but CoAP was determined to be unusable, basically. So it was removed from the specification. And then there's another one called UDS, which is meant for internal communication. So if you have an agent and you have services that you want to talk to, you can actually have an internal communication on the device. But those are the MTPs. And what we most commonly find in the field, so when we are talking about servers and devices, we typically use either WebSockets or some people prefer MQTT, but those are the most commonly used schemes. So congratulations, you just made another step. So now you know how the devices can actually communicate with the server side. Rather simple. So next point is data structure. So we have the communication going. How do we actually exchange the data, right? The data itself that we exchange is based on what is called a data model. So data models are known, you know, Tier 98, Tier 181. We've heard them a couple of times now. And those data models basically describe the data that you can use on the device. So either, you know, configure it if you have the provisioning use case, but also if you have a monitoring use case, you can retrieve it from the device to basically get the current state or get information about the operation, so what's going on. So that's the relevant information that we actually want to retrieve. Those are also specified by the broadband forum. So as Kurt so kindly introduced me, I'm a program stream lead. I'm actually one of the maintainers of those data models. So if there's anything you want to know around data modeling, you can also come to me and I will happily explain what's going on. Yeah, typically known data models are Tier 181, but there are also so-called service models like Tier 104 for voice over IP. There's Tier 135 for set-top boxes. There's Tier 140 for storage devices, and there are a couple others as well that can be used for certain specific use cases. But most of the relevant data is actually in tier 181. So how does such a data model look like? We basically have a tree structure, and the tree structure consists of objects and parameters. In USP, there are actually two new entities. So if you already know data models from the tier 69 world, in USP, you actually also have what's called an event. So that's information that you can subscribe to that will be sent to you once you have this subscription enabled and the event is basically triggered. And there are also so-called commands. Commands are things that you can execute. So you can basically call them on the device. And again, you need to have a subscription in order to receive the result for that particular thing. There are two different kinds of data models in broadband form language. There's the so-called supported data model. So the supported data model is the data model that a device vendor actually implements or offers to you. So typically that will include things like you have information about Wi-Fi, about your uplink connection, maybe some smart home. If you have some voice services, you have some information about that. If you have some other operations. So basically the data model consists of thousands of objects, and each vendor decides, I'm going to implement this, I'm going to implement this, I'm going to implement this. And that's what is called the supported data model. So that's basically the information that might be available on the device because the vendor decided to implement it. And there's also the other data model, which is called the instantiated data model. So the instantiated data model is the actual data that is available. So some of those objects can, for instance, exist multiple times. Think of network interfaces, for example, where you say, I have 5 network interfaces and I want to receive statistics of all of them. So you might have 5 instances of network interfaces inside your instantiated data model, and that's basically the data that you can actually retrieve. So independent of what or not quite independent, but the vendor basically decides to support a certain part of the data model, and then what is actually available in a particular device in the field is the instantiated data model. And of course, that will change depending on the environment and the current configuration of the system. So that was the next step. So basically, you know what kind of information you can work with. So let's talk about the actual data exchange, right? So how do we get to the information that's captured by the data model? So for that, we have the data exchange. So the protocols, tier 69 as well, but also USP, they basically support communication primitives. Those are the typical gets. So in tier 69, that would be get parameter values. You have a set that would be equivalent to a set parameter values. You have an add that's equivalent to an add object. You have a delete that's equivalent to a delete object. So if you are familiar with tier 69, you can definitely see the parallels. But here they are much more powerful. So those basically allow you to receive and set the data. So if you have some configuration, that's something that could be set using that. If you want to receive some information, you can use a get or to get it. And to manipulate the instantiated data model, you can add and delete, for instance, to create a new Wi-Fi SSID. You could create an SSID object and then configure it. And that would give you that. And equivalently or conversely, you can also use the delete in order to remove that object if the data model allows you to. There are a few new ones which only exist in USP. So one is the notify. So basically, when you subscribe to information on the device, the notify is the message that you will receive when that particular information is ready to be delivered. So if you subscribe to a value change, for instance, every time something changes in the data model, you will receive the value change. If you execute a command and that command has some results for you and you subscribe to them, then you can basically receive a notification that says operation complete. Here are the results of this command that you executed. There are also a variety of other events that you can subscribe to, but that's the gist of it. basically you subscribe to it. Whenever that particular event occurs, you will receive the notify message that is triggered by that, and then you can work with this information. So this is also what we've seen in some of the demos that enables this interactivity, where you basically say, I want to subscribe to the Wi-Fi signal strength as we've seen before, and then you will receive the information, and then the system can immediately work with that without having to be on a schedule and pull the information. For the commands that we have in the data model, we also have this operate. So operate basically allows you to execute such a command in the data model. So typical example for commands are your diagnostics. So if you want to do a speed test, for instance, you can issue a download diagnostics command. If you want to do a firmware update, you can issue a firmware upgrade command, or I think it's called an upload command. If you want to reboot the device, you can issue a reboot command. You get the idea. So whatever is implemented in the supported data model and is a command, you can basically execute with this operate instruction. And then there are also a few other ones which are not exactly available in Tier 69. So one of the ideas of USP was to make it easier to figure out what the device actually supports. So there are some messages that you can execute that will actually tell you what the device actually supports. So you have get supported proto, which is basically just saying, which version of the USP specification do we support. So that's pretty basic. More importantly, there's get supported data model. So you can figure out what the supported data model is. Again, there we have the name supported data model. So this will give you a list of all objects, all parameters, events and commands that are in the data model, including additional information like, is this parameter writable, for instance, or can we receive notification for it, or what is the type of this particular value that we would get from this parameter. So that's a very handy command to have, because it allows you to actually query the device, what it supports, independently of what is in the instantiated data model, which again is what you have in a certain situation. And if you know Tier 69, you will know that sometimes it can be painful to figure out what the device actually supports, because get parameter values will only give you the information for things that are actually existing at that point in time. So if you want to know which parameters are underneath an object which doesn't exist, you're out of luck. And that doesn't happen with USP anymore. So basically, those are the primitives that we are working with in order to interact with the device and in order to interact with the data model. So congratulations, next level reached. So let's see what else we have. Onboarding. In order to communicate with the device, you somehow need to establish a relationship between the device. In Tier 69, that process is called bootstrapping. In USP, that process is called onboarding. So basically what we do is we figure out a way to communicate between a controller and an agent, and then the agent figures out, oh, I'm not configured yet. I'm a new device. I have a factory configuration. I would like to receive some information about how I can communicate with you in the future. So what it does is it sends an onboard request to the controller, and that allows the controller to see, there's a new device or a device that doesn't have any configuration. I need to do something with the device. I need to add some configuration so that basically the communication can work also in the future. And that's what is called onboarding. The interesting part is that you can repeat this process. So unlike Tier 69, where you basically have to reset the configuration in order to do the bootstrapping again, in USP, there's actually a command that you can execute at any point in time to basically say, here I am, please make sure I'm properly configured, I'm onboarded. So there's the send onboard request mechanism. And that is also quite important if you have multiple of those controllers, and you have, let's say, one controller that basically has a full side of all the devices in the field, and then you have certain use cases that you want to have implemented on a separate controller, then this first controller could basically create a new controller object on a device, and then it can call the send onboard request message on the device, and then the device will connect to the other controller and send the onboard request notification and basically allow the other controller to configure this particular use case on the device and establish a trusted relationship. Also, one important thing is notifications. So as I said, you need to subscribe to notifications on the device in order to actually receive anything from the device. So unlike Tier 69, where you have some default events that are configured that you will receive, for instance, when the device connects, something like a boot, or when something happens, like a value change. In Tier 69, some of those events are implicit and basically triggered by the system itself. In USP, because you have those multiple controllers and you might not be interested in all information, you actually have to create those subscriptions. And if you don't do that, which is an important part of the onboarding, if you don't do that, then basically the device will never talk to you again. So you might have a connection to the device, but you don't know that the device is there because you have no idea when it was last rebooted. Which is especially important if you're using something like MQTT, where you don't have a direct connection between the two parties. But this is very important that you basically set up the notifications in order to keep communicating with the device. And another important aspect is that you need to set up the security mechanisms. So as we've heard from Sid, for example, something like, creating certificates, downloading certificates, making sure that the communication is trusted, is a very important aspect of that as well, because you might not always have the full configuration out of the box on the device, but you actually might want to deploy a separate configuration, especially if you're onboarding multiple controllers. There's a very sophisticated permission system also built into USP, and that of course needs all to be set up in order to keep communicating. So that was the onboarding. Again, another important step achieved. So what can we actually do with the device? So let's talk a little bit about direct interaction. One of the nice things of the USP protocol is that you have a persistent connection. So once you've established the connection, the idea is that the device is persistently able to talk to the controller. So of course, in MQTT, you don't know whether the device is connected to an MQTT broker, which can be problematic, but the idea is that both parties try to maintain a persistent communication relationship so that you can basically communicate at any time. So that also means that whatever your device is, wherever it is, behind a network address translation or directly connected, because it is the edge gateway, the internet router, doesn't really matter. You can basically communicate at any time and also expect to communicate at any time. So that allows us to implement some interesting use cases where we can basically say, we know the device is there, so we don't need to basically just make the device connect to us periodically. So as we've heard from Radek earlier today, using a low periodic inform in Tier 69 to basically achieve the same effect, it's very bad and it's very wasteful. And in USP, you don't have to do that anymore because you always have this connection. So whenever you need some information, you just talk to the device, you get the information. And if everything is working as expected, then that will just work. So of course, for that, we have some typical use cases where we basically say, we just received a request to deploy a new service on the customer's device. So previously, we were mostly talking about, let's say, static use cases, like someone has a telephone contract and a SIP account is provisioned on the device. So the customer could, for instance, pick up the phone and make some phone calls. But nowadays, we are seeing that those services are becoming more and more dynamic. So, for instance, operators are looking into actually deploying applications and new services on the device that directly interact with the internet. Something like you have filters, you have virus scanners, you have whatever kind of service that you actually want to deploy. So basically, a customer says, okay, I want to use this service. Whether there's some cost involved or not is a different matter, but basically you enable the service somehow and it gets automatically deployed. And since we do have the direct connectivity, we can do this at any point in time. And conversely, if the user says, well, that service was rubbish, or this application that I installed on the device is crap, you can basically also just remove it at any point in time. Then, of course, we have the common use case now of self-service apps, which is kind of important, especially for larger operators. So they want to give their customers a means to not only see contractual information and get in touch with the company, but also get some insights into what's running on the home system. So see which devices are connected, what's happening, maybe make some changes, maybe have some smart home applications. So those self-service apps are becoming more and more important. And by leveraging the direct connection, you can basically either have the app directly talk to the device, which is a little bit tricky to set up, or you can leverage the already existing infrastructure on the provider side to basically say, I'm just creating a bridge between the USP connection and our API that is driving this particular application. And that way you can basically interact with the device at any point in time, or the customer can directly use the app and interact with the device at any time. And of course, if you're looking at Tier 69, which some providers are using to actually provide this functionality, you don't have this particular guesswork of whether the device is online or not. So you don't need to send a connection request and then wait. And if it times out, then you basically say to the customer, well, your device seems to be offline, which is always a bad user experience if you click on something and then you have to wait 30 seconds and then the app says, nah, that didn't work, try again, or whatever. So that's kind of useful because you see directly the device is online, you can directly interact with it. There is very little latency, very little delay. So this particular use case profits a lot from having the direct connection and the low latency. And then, yeah, again, akin to what Radek said earlier today, you have the customer support use case where basically the customer calls in. And since you can directly interact with the device and not just use, let's say, information that was fetched from the device some time ago, but you can directly receive fresh information. You can also subscribe to notifications and get information in real time directly from a customer interaction. That's a very good use case to actually use USP because you have this interactivity. So another step achieved, basically, we've just established that you can always talk to the device, which is, of course, very handy and enables a few interesting use cases. But we also have the ability to use asynchronous interaction and those notifications. So how does this work? As I mentioned before, we have this notification system where you can basically subscribe to information at any point in time. And one of the nice aspects of this is also that everything is in-band, right? So if you use the notification mechanism, you have your persistently established USP connection. So whatever kind of information you receive, it will directly go to the controller that basically subscribe to the information. There are no other systems involved. You don't have to create some weird routing to get the information to a system where you actually need it, because you know that your interface to the customer's device is your controller and it will receive all the information that you subscribe to. So this applies to a variety of different notifications. So we have those value changes, we have those events that you can subscribe to. So some example for events are, for instance, the Wi-Fi part, the data elements, has some events, for instance, if new clients connect to the device. So that allows you also to trigger some workflows when something of interest happens in the device, be it either that you record information about that particular device, that you alert the user using the smart home app, for instance. There are a variety of different use cases where you can use those notifications. And of course, we have some very relevant use cases for those. So some popular ones are bulk data collection, since we now get rid of the external service that basically has to relay the information to our controller, and then we have to merge them somehow in the background. We can actually use this very efficiently to also drive up the data rate. So if your system, for instance, has problems doing in tier 69, the bulk data collection using HTTP, so external server, every 60 minutes, it's usually very feasible to reduce that interval to 15 minutes and directly receive the information on the USP controller. So yeah, that's what Deutsche Telekom is doing, for instance. So that's very powerful use case. And of course, it allows us to collect more data if we want to, also more efficiently. But we will also talk about another benefit that we now have with USP on the next slide. It also allows us to do tracking of changes in real time. So as we've seen from the previous demo, we can track the signal strength, and we can basically see when it changes and receive notifications. But we can also track all kinds of other changes in real time, which makes it, again, really powerful to interact with the device. And instead of basically trying to reactively do something after the fact, you can do it directly, responding to some event that happens. Diagnostic tests are also very important. So we are talking to a lot of companies that are basically keen on maintaining the quality of experience for the user. And in order to do that, they sometimes need to run some tests in order to figure out, is the quality level the same as it was before? Has it deteriorated? So running like a ping test, traceroute tests. So those are not only for let's say, problem solving if the customer is complaining about issues, but those are also very relevant in order to establish, let's say, a baseline or a measurement of what's currently going on in the network, and trying to have a consistent quality that way. That's kind of an important test. And of course, as I just before alluded to, one other important use case is, or some idea that a lot of providers have is, they basically reduce the amount of software that's directly running on the gateway, and they're implementing everything using generic services that can be just deployed to the system. So whether you have your virus scanners, your parental control, maybe some elaborate service that's running directly on the device, like some smart home management or whatever, that you can basically deploy those services after the fact. If you have like a containerization environment, you can just download them, you can run them, and then you can monitor the services that are running on the particular device very efficiently. That's another important use case, and that's also facilitated by USP, because we don't have these complicated interactions anymore where we need to have multiple connections, download something, then enable it. So in tier 69, that used to be possible, but rather complicated to achieve, because you're basically lacking this interactivity. And you have to establish many connections because the device needs some time to actually deploy the processes, for instance. So again, that's something that Sid showed, where you can basically deploy your services dynamically and just run the services that you need. So that brings us to level 8, which is the dangerous part. So what I just talked about are more or less the basic use cases, but there are some goodies implemented in USP which allow you to do more with less, or things more efficiently. So those things, for instance, are called search expressions. And what search expressions allow you to do is, instead of saying, give me all the data, you can say, give me the data based on some conditions. So I'm only interested in a network interface statistics if the interface is currently up. I'm only interested in data that matches certain criteria. And the interesting part here is you can use search expressions almost everywhere. So you can have your notification subscriptions based on those search expressions, which means that you don't get flooded with notifications that you're not interested in. You can use it in your direct interactivity. So You can use it if you do a get, for instance. You can say only give me the interface information about some interface that has the name Wi-Fi, for instance. You can use this also in bulk data collection, which means that you have the ability to basically say, I'm interested in Wi-Fi information, but only for the 5 gigahertz band or the 2.4 gigahertz band, or only for things that are actually enabled. So this is really powerful to actually reduce the amount of data that you're receiving directly on the device, and basically only receive the information that's actually important for the particular service to operate on the server. So rather than collecting a lot of data, transmitting it, using a lot of CPU power, maybe impacting the customer experience by bogging down the device to produce all of that data, you can basically say, I'm only receiving the important information that will reduce the network traffic, that will reduce the power consumption on the device and also on the server. And then again, you don't have to filter through all the data and throw away most of it because it's mostly not relevant. So that is actually super useful. And yeah, that's one of the goodies that you really only get with USP. It's a little bit underrated, but I think it's kind of an important feature that was built into USP. There are a few more, but I don't know whether I have a lot of time to basically go into them. Just check. Yeah, okay. So I guess my timing was quite good in here. So it's basically you've made it through this presentation. You now have a basic glimpse of what's going on, what you can do. Again, the time is rather limited, so I had to basically run through this. And yeah, if you have any questions, we have a few more minutes.
All right, Daniel, thank you very much for a great presentation. I really appreciate the visuals. So if you can then share how you actually made it, this, graphically stunning. You could also share that, but you could delve a little bit into how the online/offline state of a device is detected on the USP/on the USP controller side. It's actually very, very interesting and presents a very interesting, developments compared to TR69. So.
Yeah, so that's a little bit of a tricky part. So as I said, the expectation is that the state is basically maintained by both parties. So depending on whoever established the connection, that is basically the part of them to uphold them. As I said before, for MQTT, this is a little bit problematic because if you're going through a broker, then you actually have a disconnect, right, in the chain. So there's no way of telling whether your device is still connected to the MQTT broker. So you basically just can try, and if you don't get a result back, then that's what it is. Actually, our USP controller will have a built-in MQTT server function. And if you use that instead of some other external MQTT broker, that will actually give you the same level of information. So basically, we know when the device is connected to our built-in MQTT server. So you can still use the MQTT protocol, which some people are very keen on. But you also get the benefit of having the direct connectivity, and it makes the configuration a lot simpler. And of course, for WebSocket, we always have the ability to see whether the device is connected or not, within the limits of figuring out whether the TCP session still exists. you don't have a mic, so.
It's about a search question. So you know how good the implementation is for various device vendors. So thinking out loud, so alarming on the device. So
All right.
you said I can have a search expression and I can also have notification together with the search expression. So would it possibly be possible that I say if this parameter reaches a certain threshold, send me a notification?
Yes. So for thresholding, there's a special implementation. The built-in version of value change basically only tracks value changes. But you can also combine that with an expression where you say, give me that information if the value is larger than something. But that's mostly for selecting objects. There's also a threshold implementation in a data model, which is event-based. But I haven't seen that implemented anywhere. But something like search expressions to track notification for certain devices is, for instance, something that we use on the AVM devices for the demos that we've seen, where we basically say, we are interested in receiving information for this device, we create the subscription, and then we just receive the value changes for that particular device. So that's very well implemented, and it's that works pretty much everywhere already.
Now this is understood, but I could, on top of that, I could add also a condition based on the value itself.
Yes.
Yeah, then I basically have my alarming delegated to do it.
Yeah.
And Thierry, creating those streams and canceling them is all done via the notification.
Via the subscription mechanism, exactly. And there are ways in those subscriptions where you can basically say, I want to only receive this information for some time, so they can basically also self-destruct.
That was the question.
Yeah.
So they don't necessarily hit the configurative state of the device. They can be just like come and go. They would be gone after
you can, for instance, say they should be removed after a reboot. They should not persist across a reboot. But since I said you need to do those subscriptions for pretty much everything, including if you run a diagnostics test, you first have to create a subscription in order to receive the result of the diagnostic test. So what you can do is basically you can create a short-lived subscription so that you don't need to remove it after your results came back in.
The closeness to real time, how low can we go regarding the or high can we go regarding the frequency? So can we match?
That's vendor dependent. So there's no.
What is it around these days?
Well, AVM doesn't like where we are going with this, but we would have to have the notifications every couple of seconds. But right. They have said, well, we don't want to overburden the device, so they put a limit of a couple of seconds on that. So things like Wi-Fi signal strength, I think is currently at 5 seconds or something like that. But in theory, there's no limit. So if the device can send the data faster and the vendor implements that, then
yeah, got it. Thank you. With 5 seconds, we can work. 30 would be a showstopper. Then I would use get. All right.
One more question here. So regarding devices and USP, we noticed so recently at the vendor side, it's moving more and more, let's say, in this direction, but it's still in a, I would say, limited sense or limited features, mostly related to retrieving the data, not as much as maybe provisioning. And do you think that the future of USP is only at certain features, or could, let's say, dual stack way of managing devices, monitoring be the way to go, or what would be, let's say, would it be maybe a between step for this, or all in all something to
yeah, okay. So the question and the answer is basically multifold, right? So what are the interests of the providers? Of course, they don't want to throw away their already existing provisioning system and just start fresh. There's also the legacy base in the field that you just cannot get rid of. So we will definitely live for TR69 for a long time. So at the moment, the focus is mostly to implement use cases which are hard or even impossible to implement with TR69. But I think medium term, like 3-4 years, we will actually see that there are devices that also do the provisioning themselves, like the service provisioning using USP rather than TR69. And of course, probably simply because the device vendor wants to sell to operators which may not be interested in USP at the time. They will probably also go dual stack. So you have the ability to both use TR69 and USP to do the basic provisioning, but for the advanced use cases, you might want to use only USP rather than TR69 and USP.
Thank you.
Right. I guess we are also at time, so thank you very much.